Hi, welcome to Nomis Academy. In this video, we are also going to learn the rules of differentiation number 2, which is the chain rule. In the previous video, I explained the first rule of differentiation, which is sum and difference rule. In this video, we are going to learn how to use the chain rule to solve problems. Now, chain rule is used whenever we encounter a function of function. That is, a function in this form. If y is a function of u and u is a function of x, when we have a problem in this order, that is function of a function, we apply chain rule to solve those kind of problems. Then the derivative dy over dx is equal to the y all over du multiply, we use dots to symbolize multiplication, dy over du multiplied by du over dx. So whenever we come across problem of this form, that is y is a function of u and u is a function of x, we use chain rule to solve those kind of problems. One major thing we must learn how to do using this rule is we must learn to identify the inner function and then ascribe it as u, and then we go ahead in the solution. Alright, let's pick the first example. Have example 1. Find the derivative of y equal to 3x squared plus 5, all raised to the power of 6. Alright, you can see this function. Y is a function of the whole thing we have raised to the power of 6. Meanwhile, we have another function inside the bracket. So we can liken this to be a function of function. To solve this problem, solution, we're going to say let u equal to 3x squared plus 5. When u equal to 3x squared plus 5, then y becomes, the whole of this is now our u. So we write u raised to the power of 6. So since we have this, we are going to differentiate u with respect to x and then differentiate y with respect to u. To do that, we have the u all over the x. 3x squared, or no, finding the derivative of 3x squared, and that will be what? 6. 2 times 3 is 6x. 2 minus 1 is 1, so we have 6x. Then when you find the derivative of a constant, you have 0. So the derivative of the whole of this is 6x. So we've gotten the u over the x to be 6x. Then we are going to differentiate y with respect to u. So we have the y all over the u equal to, then we have 6u, 6 minus 1, which is 5. That is 6u raised to the power of 5. Alright, now we have our u, we have our du over dx, we have y, dy over du. Now we are going to say using chain rule. And the rule says the y over dx is equal to the y all over du multiplied by the u all over dx. Now I'm going to slot in the u here and the y here. So that will be the y over the x is equal to the y du is 6u raised to the power of 5. 6u raised to the power of 5 multiplied by du dx is 6x. So we have 6x. Now multiply the two together. The y over du is equal to, or the y over the x is equal to 6 times 6 is 36. And then x times u raised to the power of 5 is x u raised to the power of 5. Recall, we said that u is equal to 3x squared plus 5. U is equal to 3x squared plus 5. So we are going to substitute the value of u in the derivative. So that will be the y over the x is equal to 36x into u is 3x squared plus 5 raised to the power of 5. So this is the solution to the problem given. Okay, so let's pick one more example. Example 2. Find the derivative of y equal to 3 all over the square root of x raised to the power of 4 minus 5. Alright, we have this problem. We have 3 all over square root of x raised to the power of 4 minus 5. What we need to do, we're going to write the radical in the initial form or an index form. So that will be y equal to 3 into x raised to the power of 4 minus 5 up raised to the power of minus half. So this is the index form of the problem given. Alright, solution. Now we are going to identify the inner function, which is u. X raised to the power of 4 minus 5. X raised to the power of 4 minus 5. So let u equal to x raised to the power of 4 minus 5. Then y becomes 3. The whole of the bracket is now the u raised to the power of 1 minus 1 over 2. I'm going to differentiate u with respect to x and then differentiate y with respect to u. So that will be du all over the x equal to, this will give us 4x raised to the power of 3. Okay, 4x raised to the power of 3. In case you would like to know how we got 4x raised to the power of 3, you can check the previous video where I explained how to differentiate a polynomial function. Alright, the next one, we are going to differentiate y with respect to u. And that will be dy over du equal to minus 1 over 2, we multiply 3. And that will give us minus 3 over 2 u minus half minus 1. So that will be minus 3 over 2 u minus half minus 1 is minus 3 over 2. Alright, we have du dx and dy du. So we say using chain rule. Which is the y over the x equal to the y over du multiplied, or we use the conventional sign, multiplied by the u over the x. Alright, I'm going to substitute the value of the u dx in the chain rule and the y du in the chain rule. So that will be dy over dx equal to dy over du is minus 3 over 2 u raised to the power of minus 3 over 2 multiplied by du over dx is 4x cubed. So let's go to the other side so we can finish the solution. Alright, we have the y over the x equal to, let's multiply through, 4 divided by 2 is 2, and then minus 3 times 2 is minus 6. Minus 6 x raised to the power of 3, and then u raised to the power of minus 3 over 2. Now recall we say u is equal to x raised to the power of 4 minus 5. So we are going to substitute this in the derivative. So that will be the y over the x equal to minus 6x raised to the power of 3, and then our u is x raised to the power of 4 minus 5 raised to the power of minus 3 all over 2. Alright, to write this in the standard form, and that will be dy over dx is equal to minus 6x cubed all over the square root of x raised to the power of 4 minus 5 raised to the power of 3. So this is the standard form of the derivative. This is our final solution. Take this as your assignment and share your answer in the comment section. Find the y over the x for y equal to 6 all over the cubic root of 6x squared plus 1. Thank you for watching. See you in the next video. Bye.